Attention, ladies and gentlemen! It's a pleasure to be here on another session of Lean Six Sigma for All. On a scale from 0 to 10, please, how is my audio? Mainly my audio. And today we will be deep diving on one of the most important graphical tools in Lean Six Sigma. Okay, so we'll be using this software here. Do you guys know this software? And by the way, where are you in the Lean Six Sigma journey? Today I'll be deep diving on BoxPlot. Okay, guys, just once again, yes, okay, wonderful, excellent, beautiful. So type here for me, where are you in the Lean Six Sigma journey, so I can calibrate my words when I am explaining BoxPlot. Okay, and you can find BoxPlot here in Graph and then BoxPlot, simple like that. And it's interesting because when you are using Minitab, you know that when you just point your arrow to the tool, you will have few important words. So examine the center and spread of your data by plotting the median, the quartiles, and any outliers. Let's talk about that. Works best with samples of at least moderate size, meaning more than 20. Yeah? Wonderful, excellent. So let's take a look here, BoxPlot. You know that when you click in Help, yes, you will be opening up. Yes, on the left side, almost always you have overview, data considerations, and example. So I love to use the examples that we can find on Minitab. So take a look. A plant fertilizer manufacturer wants to develop a formula of fertilizer that yields the most increase in the height of plants. To test fertilizer formulas, a scientist prepares 3 groups of 50 identical seedlings. A control group with no fertilizer. Muito obrigado, Luiz. Ótimo, obrigadão. Valeu. With no fertilizer, a group with manufacturer's fertilizer named Grow Fast, and a group with fertilizer named Superplant from competing manufacturer. After the plants are in controlled greenhouse environment for 3 months, the scientist measures the plant's heights. Okay, so we have pretty much 3 groups. Yeah, so let's open up here. Then Minitab will be opened again. So fertilizer, height, grow fast, and superplant. It's not exactly connected to BoxPlot, but there is something that you can do when you have when your data is stacked. Yeah. That you can unstack columns, but before that you can kind of take a look on your data. There are many things that you can do here, but one of the things that you can do is simply to for example. I like this functionality a lot. There's other ways to do that. But when you go like to recode, you can come here to text and just place, this column, fertilizer, yeah, and recode individual values. I will show why do I like that, because when you do that, you can check, how many classifications you have, and sometimes you have some typos, and you definitely don't want to have like super plant and maybe super and then you have a space and then plant. It may create problems for you. Okay, so this is a very, very cool functionality. Yeah, you can also do, let me see if that would be helpful. Stats, you may try stats tables. Let me see if this one would be interesting. Yeah, it may be interesting. Stat tables tally individual variables, just for you to have an idea of how many data points you have per fertilizer. So once again, it has nothing to do specifically with BoxPlot yet, but it's like preliminary analysis that you can do. And here, because I'll be running an individual BoxPlot first, I want to separate, this data into different columns. We call this unstack. So unstack columns, data, unstack columns. Yeah, fertilizer. I want to, in fact, to split height considering fertilizer, okay, as the variable to separate for me, as the variable to be used, like as the main criteria to separate. Okay, so I will put in a new worksheet, so I keep both. So I have grow fast, known, and super plant. From 0 to 10, how much are you following me from 0 to 10? So now I'm gonna take like column C2, okay, and I'll just go ahead and run a box plot, simple box plot, known. Yeah. So the very first, I have 5 tips for you guys today. The very first tip that I have for you is, here in BoxPlot you need to know that we cannot check anything related to trend differently from time series control chart. BoxPlot and histogram, we cannot check anything related to trend. Okay, this is very important to know. We don't know when we had a certain data point, or sometimes an outlier. We don't know when. Okay, Marcelo, in comparison to histogram we can define, or at least have an initial picture of the probability distribution. Yeah, and for BoxPlot we do not have that. We do not have that, Marcelo. So with BoxPlot we cannot have an idea of the shape nor evaluate trend. So what's the value of BoxPlot? What's the value of BoxPlot? BoxPlot is very useful to give you an idea of central location and also spread regardless the probability distribution. Okay, so the very first tip is use BoxPlot. Here I will be dissecting one simple BoxPlot, but You definitely want to consider using BoxPlot with multiple data sets. Yeah, normally, just one BoxPlot, like a simple BoxPlot, just one Y, normally it is not helpful. Okay, so the very first tip, yes, to use multiple box plots. Okay, so you can compare spread versus across different data sets and also location. Yeah. A second tip before I start dissecting BoxPlot is every time that your BoxPlot is the more symmetric, and what do I mean by symmetric? The closer, the median is to the very center of this box, and I am looking at this box vertically, yeah, and the more similar these lines here are, the higher the chance that your data behaves according to a normal probability distribution. So let me just show you a simple example here with two completely different probability distributions. So let me do with normal and exponential. Okay, so let me run here 100 data points with normal and 100 data points with exponential. Okay, so if I run a box plot here, with normal, even knowing that I have this outlier, you see that it's a pretty, we can argue that it is pretty symmetric, especially if we compare with exponential. Let's put side by side here. Yeah, so please, from 0 to 10, how much do you understand that this box plot here is way more symmetric than this box plot here? Yeah, from 0 to 10, how much do you understand that? Yes? Amazing? Wonderful. So obviously, here when I run a box plot, okay, with groups, height and fertilizer, yeah, I have an amazing opportunity to understand which one has, in terms of location, the best result. I can see that grow fast has the highest height. Can you guys see that? And known, yeah, has the shortest height. I can also see that super plant apparently varies more than known and also grow fast. Can you guys see that? Yeah. Can you guys see that? Type yes if you can see. Yes? And so let me go back now to my simple box plot. Yeah. And let's fully understand what's going on here. Okay. So this is for known. Yeah. And let's fully understand what's going on here. Okay. So I want to use an Excel so we can fully understand, interpret what is going on here. So, first of all, what is this center line here? Okay, so let's fully understand what is this line here. So we call this Q2 or median. So why 18? Why 18? So you can simply come here and median, and you can ask Excel to calculate median for you. Okay, then Excel give you 18. Or if you prefer, you can sort you can sort this data. Yeah. And then we can argue that we have how many data points? Yeah. We have 50 data points. Okay, 50 data points. So here we have the data, and here we have the position. Okay, data and the position. So median, we are pretty much taking the number that is, we sort the numbers and we take the one that is in the middle. Marcelo, what do I mean by taking the number that is in the middle? If I have, for example, 3 data points, 5, 9, and 15. 5, 9, and 15. Median will be 9. Simple like that. Simple like that. Marcelo, what if I have 4 data points? 4, 9, 15, and 22. Then I need to take the 2 data points that are in the middle and take the mean. Yeah? And it's interesting because there is a formula. There is a formula for the median. Okay? So you can use as a formula n minus 1 plus 1 divided by 2. The number that is in the position n plus 1 divided by 2. How many data points do I have? How many data points do I have here? I have 50 data points. So 51, 50 plus 1 divided by 2 will give me 25.5. So what is 25.5? Well, 25.5 is the number that is between 25 and 26. So what's the number that is between 25 and 26? The number that is between 25 and 26, 25 is 18, 26 is 18. Yeah? The number that is between 25 and 26 is really 18. Yeah? Might chegou. Grow fast and super plant. Let me go back there for you. Might chegou. Very simple. Very simple, okay? See that we have 3 data groups: grow fast, known, and super plant. Okay? Grow fast has a median around 25, let's say. And super plant has a median of 21. So once again, we are talking about 25.5. Take a look, 25.5. And here the median, this line here, is 21. So we have an evidence that in terms of location, and what do I mean by location? Mean or median or mode, yes, central tendency. Grow fast is better, yeah. It's the height is higher. Do you understand that? Might chegou? Please let me know if you don't understand. I can explain in a different way. And also, if you take the spread, meaning if you take the spread, let me do something different here. If you take the spread from this point to this point, you know, if you take this in comparison, yeah, I think this one is beautiful. Take a look from this point to this point, and here from this point to this point. It's hard to draw with this pencil here, but I hope you can see that A seems to be greater than B. A seems to be greater than B, suggesting that the variation in superplant is greater than a grow fast. Okay, beautiful, excellent. So we took here median, that is also known as Q2, and once again there is a formula for that. There is a formula, you know, Q2 equals and I'm gonna write in very simple words. It's the number in the position n plus 1 divided by 2. Okay, I'll make it super easy for us to understand. Okay, very simple. Very simple. And then we do have other two lines, you know, we do have other two lines in our box plot, right? We do have Q1. We do have Q1. That is pretty much this line here. That is 15. You know, let's understand what is Q1 and let's understand what is Q3, because if we understand Q1 15, Q3 23, we have the interquartile range that is nothing but the height of this box. Okay? Yeah? 8. 23 minus 15. 23 minus 15. So if I take 23, yeah, let's see how can we find, you know, this number. Let me know if you guys agree that if Q2 is the number in the position n minus 1 divided by 4, what can we have if we take n plus 1 divided by 4? Okay, so n plus 1 divided by 4. So what do we have if we do that? Yes, n minus 1 divided by 4. So 51 divided by 4, we would have the number in the position 12.75. 12.75. So where's 12? 11, 12. 12.75. Let's suppose we had here, yeah, 16. The distance between 15 and 16 is 1 in this case. So 12.75, I would need to interpolate and take 75% of the distance, of the difference. The difference is 1, yeah? So 75% would be 0.75. So if 13 was 16, I would have 15.75. Yes, but in this case we have the same number. We have 15 and 15. Yes. So what is in the position? What is in the position 12.75? It's really 15. Yeah. It's really 15. Is really 15. Yeah. And then for Q3, I just need to take, oh, and this is Q1. For Q3, I just need to take 3 times n plus 1 divided by 4. So in terms of position, let me put here position. Here we would have 51 divided by 2. Yes. Here we would have 51 divided by 4. And here we would have this guy here times 3. Yee-hoo. We would have this guy here times 3. So what's the number in the position? Position 38.25. Yeah, 38.25. So let's take a look here. 38.25. 38 and 39, we have the same numbers, 23. So easy. 23. That's why when we come here, we see the 23, the number 23. Marcelo, why is it so important to have like this interquartile range? Like, why is it so important to know the height of the box? Because let me know if you understood, type understood, if you understood that it is important to have Q3 and Q1 so you have the interquartile range. Because how high is the box is a good, very good first indication of process variation. Okay, it's kind of it's not very much close, but many people use as an initial estimation. If your box plot is symmetric, it's not extremely close to standard deviation. Yeah, and we can compare these numbers here. Okay. So if I take a look on the 3 different box plots, I can see that Grow Fast has the shortest, interquartile range. Yes, has the shortest interquartile range. And then you may even color code, for example, if you wanna change here, for example, to green. Yeah. So my 30 tip for you on BoxPlot, on multiple box plots, is to pay attention on the size of your box. Many people call BoxPlot as box and whiskers, okay, like in the cat, because of these little these lines that they look like whiskers, okay? Guys, I don't know if it is because of commercial hours in Africa. I am finding the chat too quiet in comparison to the number of people. So I don't know if you guys are multitasking or if you are not understanding. Because if you are not understanding, I can explain in a different way. So from 0 to 10, how much are you following me here? From 0 to 10, how much are you following me here? Yeah? Okay, beautiful. Okay, okay. Amazing. Yeah, and guys, if you are taking notes of these formulas, that's okay, but remember that in Minitab help, you will be finding, all these formulas, okay? So here at the bottom, uh, key results, Then we have quartiles. See, we have the formulas here. Yeah, or pretty much these concepts that I have mentioned right now. Yeah. Then you have lower limit and upper limit. Yes. So if you take Q1 as we have here, Q1, so lower limit, yeah, Q1 minus 1.5 times interquartile range. Let's see what we have. Yeah, so we are talking about Q1 minus 1.5 times 23 minus 18. Yeah. So we have 5.25, and upper limit is Q3 plus 1.5 times interquartile range. Yeah, so we have Q3 plus 1.5 times this guy here minus this guy. Okay, and now there is something very interesting, because let's see if we have 5.25 in our numbers. We don't have 5.25. So if you take in our box plot, okay, the extreme here, Q1, this extreme, you know, you will see something very interesting. Very interesting. You will see that, see, whiskers, we don't have 5.25. We don't have 5.25. Yeah? We have 8. So what is going on here? We have 8, right? So let me just see if I'm using the same. Just 1 second, guys. Just 1 second. Boom, 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 boom. Just 1 second. I believe I have I have changed the sequence here, right? But I think with these numbers will be good. Yeah, the problem is that I took the position. So it's not F, it's G. It's G. Yeah. So G5 and G4. Not the position, it's really the number, right? So equal Q1 minus 1.5 times 8, right? And here we have Q3 plus 1.5 times 8. Yeah, so 6. We don't have 6 here. We don't have 6. So what's going on here? Why are we using 8? Why are we using 8 and not using 6? And why are we using here at the top 27? Why are we using 27 and not 35? Yeah, Because as part of the BoxPlot theory, we will be adjusting the lower limit to the closest value in our data set. So the closest value going up is 8, number 8. And the same thing at the top. At the top, I would be adjusting the 35 to the closest one, that is, in this case, 27. If I sort the numbers, I have here 27. So that's why I have here, yes, as the extremes for the whiskers, yes, 8 and 27. 8 and 27. Yeah? Marcelo, do I need to know all this math behind BoxPlot? What do you guys think? Do you need to know all this math behind BoxPlot? What do you think? Probably it will not make you a better black belt necessarily. If you are a teacher, an educator, you definitely want to know what is behind, these numbers. And you saw that the math is very simple. It is very simple. And you can practice, So this is another tip for you guys. I prefer that you master the concepts and principles and know how to operate the tool, meaning how to input data and how to interpret your results, okay? Then having all the formulas at the top of your mind, okay? Type understood if you understood that. This is another important tip, okay? So when will we be using BoxPlot? Once again, an important tip is use BoxPlot when you have multiple data sets. Multiple data sets. If you have just one data set, normally there is no reason for using a BoxPlot. So once again, when you have multiple data sets, in this case, one type of fertilizer, another type of fertilizer, and nothing. Okay? Another important tip is you must have at least 20 data points. Very much important. Okay? But if you have normally more than 100 data points, you may suffer with another problem. So take a look here. Let's generate 1000 data points, okay? Data. Let's generate here 1000 data points. 1000 data points. So see, you have many outliers. You have many different outliers. See, 3 outliers plus 2. So you have 5 outliers in total. And probably if you run an outlier test, you will see that we have pretty much, let's say, as a real outlier, just one. Yeah, just one outlier. So why am I saying that? The larger your data set, the higher the chances that you have false alarms. Okay? And then one of the things that you can do is exactly as I did here. I ran an outlier test, basic statistics, outlier test. And in case, let's suppose we did not have this data point, okay, 600. Let's suppose we don't have 600, yeah, this data point here. So let's run the outlier test again. So we don't have outliers, but if you run a box plot, you will see that we are still seeing, you know, outliers. We are still seeing outliers, okay? So once again, if you ran outlier test and you have an evidence that you don't have outliers, you may consider going in data view, and then you just uncheck outlier symbols. You can just uncheck outlier symbols, but once again, only if you ran your outlier test and you saw that there is no real outliers, okay? Wonderful. So once again, you need to have at least 20 data points, yeah? But please be careful, because if you have more, normally when you have more than 100, you start having these kind of problems with false alarms, yes? Beautiful. Another thing is, remember that you can use BoxPlot regardless the probability distribution. This is not a tool that you should be using only when you have normal probability distribution. You can use with any, it's a non-parametric graphical tool, okay? So you can use regardless probability distribution, okay? Remember this tip that I just shared with you. Be careful. Be careful with false alarms, okay? And this is valid for BoxPlot and for all the other tools and techniques. If you are teaching that, you definitely want to know, you know, the formulas and everything. But please do not overcomplicate, you know, the usage of the tools. At the end of the day, we want to be able to apply the tools and techniques, okay, and pretty much extract from there important insights, okay? Questions, please, questions. All questions are welcomed. Questions, all questions are welcomed. Questions? Papá. Vamos dar um oi pra turma lá. Oi, pessoal! Oi, pessoal! Manda beijo, tchau. Guys, if you have no questions, once again, I hope you've enjoyed, you know, this session. Tem um pãozinho na chapa, nós já vamos comer ali. I hope you guys have enjoyed. Thank you so very much, and I'm looking forward to seeing you guys again in our Lean Six Sigma for All, okay? Thank you so very much. Bye bye, bye. Dá tchau. Tchau, tchau, tchau. Tchau, pessoal. Era uma vez um cavalinho que andava muito devagarinho. Aí o Arthur falou pro cavalinho. É? Pro cavalinho? Cavalinho, anda mais depressa. É? Aonde? Ah, agora entendi. Agora entendi. Guys, bye bye. Thank you.